You are listening to the Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the advancing journeyman developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast. This episode is sponsored by Datadog.
Commander on deck. Command Query Responsibility Segregation, or CQRS, is a development practice closely associated with domain-driven design. It creates a logical and often physical barrier between operations that retrieve data and operations that change the data in some manner. Event sourcing takes that same separation and persists the commands separately so that they can be analyzed and replayed as needed. In this episode, we're going to discuss how these two concepts go hand in hand. But before we get started, Will, what have you been fighting this week?
Well, I have been absolutely slammed. There is so much stuff going on at work and so many projects. I'm able to work from home, a fair bit just because it's a quiet environment and I could just go. Like, they know they'll get a 10-hour day out of me.
Nice.
And that's kind of been necessary. It's going to ease up here pretty soon. So it's not like a permanent death march, but there's a lot of opportunities and I just kind of have to push through.
Yeah. I remember when the front end developer I work with right now and I got pulled off of our project to finish up another one. We had like a month to take a project that was 3 sprints behind and finish it out.
Yeah.
Our executive director asked the lead developer, hey, what do I need to do to get these guys what they need? Do I need to get a conference room they can just go sit in? What do they need? And he said, send them home. This was before we had work from home. He's like, send them home. Those two will work day and night if you just let them work from home.
Yeah.
And they'll knock it out. And sure enough, we did.
Yeah. And I mean, the thing is, my home setup is, it works really well for that. I have 4 monitors. I could set a tablet there with my specs, so I can split 4 widescreen monitors so I can look at 8 documents at once if I need to, and that or more. Mm-hmm. That's really helpful when you're doing a lot of little, knockout JS components, and they're calling to, they're talking to parts of a page, and then the page is connected to the server, and then you've also got a controller in there because you're, switching between web forms and API, and you haven't quite been able to completely make the switch. Yeah. And you're, all the way back to the database. And so it's just, there's a lot of stuff going on. Other than that, I have been a lazy slob. I have not been getting my stuff done. A lot of my goals for this year just are not really moving at the moment. I've had new flooring to put in the basement. I got a space heater so that I could, lift weights when it's cold. Yeah, the space heater's half put together. It's just sitting there. It's been sitting there for 4 weeks. And the new flooring's in a pile sitting there. I haven't meditated. I have not been doing the bulk cooking as much for the week for myself, although I did it yesterday. Yeah, I'm having a hard time getting going. I think maybe that break in December was a little bit longer than I needed.
Well, I think part of it was you were on break, but you were still here.
Yeah.
It's really funny that you mentioned moving forward because I've actually been moving a lot, working towards my goals. I've been walking more. So there's a kind of a path that if you go the big circle and then the little circle, it's a half mile. And so I've been walking my dog some on that. But I ran into an odd error this past week at work. We're generating GUIDs, or globally unique identifiers, when we are creating data classes to send to the database. That's where it generates. So if one doesn't already exist, it creates one and puts it in there. Well, a funny thing about AutoMapper is that even if you're creating the map on the fly, it apparently caches it for reuse. So we have several objects with the same GUID because of the way that I had tried to...
You did .useValue.
Yes, I did.
Yeah, because what it'll do is it gets that value, and then from then on...
Yep. And that's exactly... I was trying to be clever, and, You
probably could have passed it a lambda instead.
Well, I originally was passing it a...
Because what happens is if you do .useValue and then you say, okay, .nuke_with, it gets that GUID and it builds stuff behind the scenes.
So what I originally was passing it was a call to a function that got the new GUID, and it still, like, I thought it was, okay, it's because I'm calling the static function that it's doing it. Took that out, put it in as,
because basically you need a callback instead of a
well, that's what I was doing, and it was still messing up because it was doing, I guess, the callback and then getting that and still caching it.
Yeah, because you would need a method that takes a either a func or some kind of expression tree type.
Right. Yeah. If I could pass in an expression tree, I don't know if an expression would work, but definitely a function would work for that.
Yeah.
But anyways, I was able to pull it out and just set that aside because of the way we're doing things. It wasn't a terrible thing, but it was a weird bug that we spent like an hour dealing with, trying to figure out what was going on.
Yeah. And some of that code, I mean, because you think about just how crazy the innards of that thing are, and just what you got to do to configure it and get what you think you're going to get.
Yeah.
I mean, because it's not a simple problem. It's nothing wrong with AutoMapper. It's just like, hey, this is something that is nasty, complex configuration that has to be done that way to configure nasty, compiled on the fly code. And
that still, even having to pull that out and manually put that in, it's hundreds of lines of code that I don't have to write by using that. So
you may not like the horse manure, but it makes the carriage go faster.
Right.
Yeah.
Speaking of smelly things, I'm presenting my Code Smells talk again for the new Covalence class tomorrow. I took the afternoon off because after the talk, I'm going to go see the eye doctor. Since I've been working from home, I wear my glasses a lot more during the day, and those haven't been upgraded since I was in medical school.
I need to do that as well.
But speaking of upgrading glasses, I've got something fun for your eyes in IoTs. Intel is picking up where Google left off. This week for IoTs, I have a product called Intel Vaunt Smart Glasses. However, unlike Google, Intel didn't go for the sci-fi look that Google Glass did. They went for more of a hipster, full-rimmed fake lenses look. They actually look like you're wearing a pair of regular, if not a little bit bulky, the bulky plastic kind of glasses. You and I both like the thin metal frames.
Right.
But like the hipster look, bulky plastic rims, that's what they look like. The really cool thing is you don't even have to get fake lenses. Like for you and I, we could get prescription lenses in these and have smart glasses. Yeah, it's really neat. Intel's goal isn't to change the way you look at the world, but to integrate into your life as seamlessly as possible. The glasses do have to be fitted to your face. Those of us that wear glasses regularly know that process, but also they have to measure the pupillary distances. Going along with the unobtrusive nature of the glasses, the heads-up display disappears when you're not looking at it. So it's not just there off in your peripheral. You're not purposefully reading or...
So you're constantly doing a double slit experiment.
Yeah.
That's what you're saying.
So it's not just like hanging over here. You have to like look at a specific spot and then it drops down. It's like clicking on a menu kind of thing. It's a really neat concept. I like it.
I wonder how that works when your eye starts twitching.
I have no idea.
I'm thinking, like I've been sitting in traffic before and my eye will start twitching because traffic irritates me. It's kind of like high school. The dumbest person sets the pace. Like that kind of environment just does not make me happy. And so like my eye will start twitching and I'm going, I don't know if that'll be okay because it'll be clicking that menu.
Well, maybe. I think maybe you have to look at it for a certain amount of time. I'm not sure exactly how it works because I haven't tried this out. As soon as I can get my hands on a pair of these, I'm going to, because this is what I've wanted for a long time.
Yeah.
This is such a neat idea. I'll have a link to the Verge article that I read on it. I actually read 2 or 3 different articles on it. So it's great. I think Intel has the right direction here. I like where they're going with it. My biggest complaint about Google Glass was that they weren't glasses.
Yeah. It was like this big freaking headset thing, wasn't it? Wasn't that Google Glass? No, that was the other. I know which one I'm thinking of. It wasn't.
You're thinking of the AR stuff.
Yeah.
Now, Google Glass was the little band that went around your head with the one little screen that popped out, and you looked like
Mr. Peanut.
Yeah,
like a like a steampunk, or not a steampunk Mr. Peanut, but like Mr. Peanut and the Jetsons. Yeah, I do remember that now.
So, who are we sending a water bottle to this week?
Well, we got a tweet from Mike Moore. Said, I listened to an episode of the Complete Developer podcast yesterday, and it was refreshing to hear the host talk about the personal and human side of things.
Thanks, Mike. We both work as developers in our day jobs, and that's kind of what we wanted to do with the podcast, is to bring out the personal and human side of things and how they relate to stuff like the technical or the soft skills or the different areas of being a programmer. Send us a DM with your contact information, because we've got a Complete Developer water bottle just for you. And guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all of our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Path and Tumblr, and have several photos now posted on Instagram. Check us out every Monday on Facebook and Twitter Live, where we talk about what's going on in the tech community and answer some listener questions, or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
A thank you to our sponsor, Datadog, a cloud monitoring platform bringing full visibility to dynamic infrastructure and applications. Create beautiful dashboards, set powerful machine learning-based alerts, and collaborate with your team to resolve performance issues. Datadog integrates seamlessly with more than 200 technologies, including Google Cloud Platform, AWS, Docker, PagerDuty, and Slack. With fast installation setup, plus APIs and open source libraries for custom instrumentation, Datadog makes it easy for teams to monitor every layer of their stack in one place. But don't take our word for it. Start a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/complete-developer to get started.
Command Query Responsibility Segregation, or CQRS, is a way of designing the code in an app that talks to a database. It creates a logical separation between operations that mutate data and the operations that merely retrieve it. Because the load characteristics of reading and updating data are often different, this practice can have a profound impact on how well your application runs.
In addition, event sourcing can help your application collect data that may not be considered valuable at the time of design, but may be very valuable later. Event sourcing is a way of modeling your data as the result of a sequence of events rather than only keeping track of the current state. Sort of like your bank account.
Mm-hmm. So, just for a little bit of information to you guys as a listener, this episode started off as on my plate a quarter or two ago.
Yeah.
And I worked on it for a while, and that's where the stop writing cruddy apps came from. And then it got to this quarter, and Will and I were talking, we were like, we really want this episode to come out. But I was like, I'm struggling to get enough information that doesn't go way deep into something else to explain it.
Yeah.
And so Will said, well, let me take it. I can explain it. I've got a better understanding of it. I'm like, all right, cool. That's fine.
And then I ran with it. And I was like, they really need to have domain-driven design in the mix before they do this so that they can understand kind of where this came out of. Mm-hmm. And so I wrote the DDD episode and then wrote this and then tacked on event sourcing because...
So if you haven't done so already, go back and listen to our episode that came out a couple of weeks ago on domain-driven design to help understand what's going on in this one.
Yeah, I think that's almost necessary just because of all the vocabulary. Because when we put all this stuff together, it's pretty much required that you go through the domain-driven design stuff first, just because of all the vocabulary and the understanding of how that way of modeling systems is built, so that you can understand that this stuff isn't quite built on top of it, but it complements it very, very well. And we use a lot of the same terms to describe things.
So we're going to start off talking about what is CQRS. Well, as we stated already, it stands for Command Query Responsibility Segregation. And a query is an operation that only reads data, whereas a command is one that changes data in a data store.
Essentially, the code that simply returns data needs to follow a separate path than the code that actually alters the data. The idea is to explicitly separate operations that retrieve data from those that alter it so that it can be reasoned about separately, scaled separately, and even secured separately.
Yeah, hence the segregation part of CQRS.
Right.
You're taking the two different responsibilities and you're saying, hey, whereas with something like a CRUD app, and you may want to go back and listen to our Stop Writing Cruddy apps for some of the reasons why this type of design came about.
Yeah, and this, I do want to stop here and point out that you probably are not going to want to start with event sourcing as you're building an app, especially, like if you're kind of green, because it's a very challenging way to approach things and it takes a while for it to sink in. The other thing is a lot of times you don't really know the domain model well enough starting out to actually do this effectively. In other words, you're going to be changing, we'll talk about this in a bit, but you'll be changing the signature of your events a lot, and versioning is a whole nother can of worms that we didn't get into here. This is a tough episode as it is.
No. So next, we're going to kind of get into a little bit of the history of CQRS, and Will pulled this from Wikipedia, which is where he gets most of his things.
Well, I mean, just like if you need definitions and stuff, like
I'm picking on him.
I'm a little hesitant to go much beyond definitions. When it starts getting into opinion, it's like I don't know who wrote this.
Yeah.
And I don't have time to research the author and go, do I actually trust them or not? And there's some things I've seen on there that make me a little doubtful about trusting it too much, but for definitions, it's pretty good.
So CQRS was originally coined by Bertrand Meyer while he was working on the Eiffel Tower. I mean, the Eiffel programming language.
Yeah. So Bertrand Meyer's work stated that every method should either be a command that performs an action or a query that returns data to the caller, but not both. In other words, asking a question should not change the answer.
Well, more formally, methods should return a value only if they are referentially transparent and therefore possess no side effects. Sounds very functional.
Yeah.
Anytime I hear no side effects, I think functional. So
well, it kind of is. It's so that your query side can be. Mm-hmm. Now that we've kind of started out, let's talk about the benefits to the command side of the equation that this brings you. The first is it makes it easier to take advantage of eventual consistency, meaning that your writes to the system don't necessarily have to be slowed down by indexes that you've put in place to make reads faster. I'll give you an example. We've got a system at work that processes a metric crap ton of transactions. And as we're writing to them, we write to this one table, and it's got a fair number of columns. It's not excessive, and it writes and writes and writes and writes. Well, those stay around. Later on, somebody wants to look at history, and they want to query. Well, for the query to be fast, you've got to put an index on that table. Right. However, when you write to the table, if you write the record, you also have to update the index. Yeah, and that can be slow. Mm-hmm. Especially as you get more indexes. So our growth in indexes is constrained by, basically our read speed is constrained by our write speed, or our write speed gets constrained by our read speed, if that makes sense.
That makes perfect sense.
And so this pulls those two pieces apart. So you do the writes and it's like, okay, it's out there. For the purposes of recording that write, you immediately fire it and you come back. And then the construction of an aggregate happens elsewhere. In other words, it's like a fire and forget type deal.
So this means that commands only have the information required to execute the command.
Right. And that's another big thing that we've noticed, like in CRUD apps. So you want to just have the information required to execute the command rather than the entire aggregate upon which the command is run. So let's take, for instance, a invoicing application. You've got the aggregate root as the invoice. You've got detail lines. You've got your various taxes, shipping charges, different areas of the thing like hanging off of that, right? So you get this big wad of stuff. Now, what do you want to change on this invoice? Assuming that invoice isn't like fixed forever. You want to change, oh wait, this is actually going to this other person at this house. So you're changing a name. You don't want to save the entire invoice to do that. You only want to save the name. Mm-hmm. And this doesn't sound like too big of a deal, but I'll give you an example of why this is important. Let's say that you have a web page that's got user account information, and it's a page that the user edits. Okay, they can go in there, they can change their name, they can change their email address, they can change a few other things. On the user aggregate root, you have a bit flag called isAdmin. If you're saving that whole object when you're saving the user versus just going, okay, they updated their name or they updated their address, unless you take specific steps to avoid it, you risk what's called a mass assignment vulnerability. And that's where somebody passes more data than they need to, like they pass an isAdmin flag when they're doing a form post, and you read it into your nice little CRUD object and you write it to the database. They just gave themselves admin access from the Google Chrome console. So it cuts down on those kind of shenanigans. It also means that you actually know what they're really trying to change and what the intent of the action was, not just, they wrote to a table.
That would deal with some of the problems that I've had where using an ORM, you have to pass the entire object back and forth. Right. Because otherwise, if you don't do that, it overwrites. If you just pass it.
Just the pieces you need, and it gets a null.
Yeah.
Yeah, the pattern, and you can use an ORM with this.
Yeah.
So the command comes in, and with that, you use ORM to hydrate the object, process the command on it, and then you save the object back. Mm-hmm. But there's a disconnect there versus it going end to end.
Yeah. This makes transitioning to a message queue architecture a lot easier because the payloads tend to be smaller.
Yeah, they tend to be smaller. And, when you start getting into a disconnected type environment, you only want to change the data that you're actually trying to change, because what happens if you and I are both editing the same thing, but we're, the same aggregate root, but we're giving it different messages. You're changing the shipping address and I'm changing the password. But if we save the whole aggregate root with our operation, that's not good, especially if it went all the way out to the browser and we messed around with it for 10 minutes and came back. That's how you get all kinds of very nasty problems to deal with. The next thing that it does is it makes commands relatively self-documenting in that their signature shows everything that's required to use one. So you don't get these surprises of, they were able to save this thing in an invalid state, or they were able to, they didn't pass all the data that was required, and it gets all the way to the database before it blows up, or it gets all the way to the monthly report before that's wrong. Mm-hmm. And so this sort of gets rid of those problems, because now you can see, okay, when they do this, here's what's required. And you can show that to a business person. Here's the message. Here's what's required for this operation versus here's how we organize our database. That by itself is extremely valuable.
Well, yeah, because they don't care about how the database is organized.
And they'll argue with you about it.
Yeah.
Which is,
I've been in those
meetings. That's why you just, you separate this out and it's here's what we require for them to do this. And they're like, okay, that makes sense. Whereas why are order details in another table? And you have to explain third normal form and all this stuff to them, and pretty soon they got a comp sci degree and you've pulled all your hair out. Another thing that this does is that it makes it where you can validate the command's requirements on the command itself rather than at the end where it gets received. So in other words, you build up a command to say, I'm editing this aggregate root. The command can validate itself before it goes over the pipe, because you may not be doing an immediate thing. You may be kicking it into a message queue and it gets processed when it can. And so you want that validation to come back immediately instead of, hey, 10 minutes from now, your thing failed because you forgot this field. Now, we handle a lot of this on the web on the front end anyway. Mm-hmm. And you would handle it in business logic on your controller class or whatever. But this puts it in the command where it's always there with the command anytime somebody uses it instead of scattered.
We do a little bit of both.
Yeah.
Where it's on the validation is on the front end, and then we have it again.
Well, you validate on the front end to get speed for the client. You validate on the back end for security.
Right. Yeah, that's where I was going with it.
Yeah. Another thing this does is it makes audit trailing easier, because audits usually correspond to actions that were taken. Sometimes you'll get audits on selects, like if it's really sensitive data, but most of the time it's updates, deletes, inserts are the things that you actually want an audit trail on. Unless it's like HIPAA data or something along those lines, then you get more constrained. But for the most part, you want that on commands. You don't want it on queries. So you can get that crap out of the query. In other words, a query doesn't have to go, somebody looked at this. Let me write it to the database.
Oh yeah. I mean, that's that's like using triggers on the database for when one of these actions happens versus when we do this at the business layer, the server side, we then have to write back to, okay, we've done a thing.
Yeah.
Though we are having to put in our created bys because that doesn't pass down.
Yeah, I know. That's a really irritating problem going from a web app to a database, because the web app's got its own connection and it's got a connection name. And so you don't you don't know who the web user is. There's nothing to tie it.
Right.
I wish they had some way to go, hey, I opened this connection on behalf of this user ID and just like put it in a variable that I can access on the database server.
That would be nice. We're doing that basically.
Well, you're putting it in the record going in. I want it to be just like it's ambient for the connection. So I can use like, kind of like I can do in SQL Server where I can say app_name and I get the name of the application in the connection string and I get that at the database level. I want it to be like I opened a connection and I added some attribute to it that says, hey, here's set the current user to this.
Yeah. Yeah. That would be awesome. I don't know that's possible.
Not a thing, I don't think.
The last benefit that we're going to talk about for the command side is that it makes replaying events easy, which can help when you learn more about what a particular action means as your domain evolves. And this has happened to me where I work several times. I mean, I think I talked about it a few weeks ago where we ended up dropping an entire story because it no longer made sense based on the domain information or the business information that we learned as we're going through the Scrum process.
And you'll do this a lot with event sourcing type implementations because your users will be doing things and you record the events. And then later you go, hey, if a user does, like let's say a user exports the data from the system and then they do, these 2 or 3 other things, that's an indicator that they're about to bail and they're about to get out of our software and quit using it. Well, we can wire that up and go, okay, find the users that have done this or detect when this stream of events has occurred and send them a special offer. Get somebody on the phone with support. Like, that's a legit thing that can happen. And you can't really capture that very well if you're not using this kind of architecture.
That's really interesting. Where I work, it's not really a big thing because they don't really have a choice.
Yeah, you're at the state. But, that makes that sort of stuff more possible. Another thing it does, like if you're using desktop apps, for instance, and, most of your desktop apps have undo. Well, how does the undo stack get implemented? There's a couple of different ways. One is you can say, okay, I have the document in whatever version it is, and every action, I'm going to snapshot this entire document and put it on the disk. And then when you Control Z, I'm going to load the previous one, which works until you get a big document or an old document. And then it's, it gets ridiculous. But if you just store the command and not the state, and the command is undoable, in other words, you've got a reversing option on it, then you can just flip it back.
Yeah, that makes sense. I follow you there.
Right. So that's a nice little thing too.
Cool. So now that we've talked about the benefits of the command side, we're going to flip over and talk about the benefits of the query side.
Yeah. So one thing that this does is it makes caching a lot easier. Because if you know that, hey, when I go through this path, it does not alter data, right? Like that's a fact. It can't alter data because this is just the query side.
Right.
There's no side effects. That makes caching a lot easier because I know that a call to this same query, unless something else has changed, is going to return
bring you the
same
thing.
Right. And so I'm not changing the answer to the question by asking it. So I can cache a lot easier just in terms of like system structure.
So one thing that we're doing where I work is, we're doing MVC, Model View Controller, with Web API, where it's sort of the database is your model, and we have data models that we pull from the database. And then I write controllers. The view is the UI, which is Angular, that then calls to the API to get that information. When I write my controllers, I have a set of get controllers that, they get by certain criteria. And that's all they do. And then I have a set of post controllers. I actually have them regioned off in my controller because it's easier because I'm like, all right, I need to go do an action on a post. I know exactly where to look.
This is a whole nother level of separation.
Yeah, well, this is reminding me of that because when you're talking, I'm thinking, well, that's sort of what we do because each time he loads a new page, it calls and gets the information.
Yeah. REST is very much structured around this kind of idea. One way to think about a web page is essentially, okay, I've pulled data out, right? And I'm projecting that into HTML.
Yeah, that's exactly the way.
It's a functional projection, and it doesn't change the data coming in. As a result, you can use memoization techniques, aka caching.
Yeah.
Another thing that this does is it also makes cache invalidation easier. So when you pull an entity out, that entity's got an ID. That can be your cache key for an entity of that type. When something changes that ID, you send a message out to all the places that have the cache, say, hey, invalidate this entity ID, and then it's done.
I hadn't thought about doing that. That makes...
Now, it's a little more complicated. Like, okay, there's an old adage in computer science that there are two things that are difficult in computer science. Naming things, cache invalidation, and off by one errors.
Yeah.
Okay, there's a reason cache invalidation is listed where it is. That's a very complicated subject, but this does kind of make it a lot easier. You have a natural cache key if you're structuring things this way. Whereas if you're doing the whole CRUD model, pulling back an aggregate root, and like, let's say it's got, again, the canonical order and order details thing, right? Well, how are you going to cache that? If you cache it by the order, different parts of your app are independently reading order details when you're not actually using proper DDD. Guess what? You've got to cache those too. And now when the big one gets changed and it possibly edits a child, you got to fix that. You got to fix it in multiple places instead of having a single ID that's for, in other words, if you access it through the aggregate root, you can kind of control access to it. Otherwise, you have to go, okay, what does this affect? And you have to remember all of them. So when you add a new one, you got to go back through all the places.
Okay, yeah, I follow you.
So it gets really ugly really quick. Another thing that this does is it makes it easier to mirror your data stores because the results of one command can be replicated to multiple data stores more easily than database mirroring will allow. And we'll go back again to the canonical order and order details thing, right? If you're going, hey, I'm adding a details line. Well, in SQL, what are you going to be doing if you're replicating those two structures, between two databases? You got to go, okay, well, I'm replicating all the orders and their details. And oh, by the way, there's a referential constraint. So SQL has to know which order to write stuff in. And then you do deletes, right? Like that gets ugly really quick. Whereas if you go, hey, I'm writing an event to a table, single event, single table, no joins, no crap. You pull it across and then you process it for the projections that you're using. It makes that a little easier. It's more data transiting the wire, but it's less work on the database server.
Yeah, I would actually like to see, for me to understand this really well, I would like to see code written this way.
Yeah, and I've seen some and I've worked with some, not as much as I would like.
Like, it's hard for me to wrap my brain around it because I have not ever seen it in practical use. Yeah. Even if it was impractical use, even if it was like, all right, here's an MSDN example that leaks memory like a sieve, it's okay because I could still get a concept around it.
Yeah. Well, I'll give you a concept. Think of your query side as your bank balance. Think of your command side as the transactions that led up to that bank balance.
I get that. I get it from that perspective. I'm talking about a practical code perspective. I want to see the actual code of how this is implemented to really, really understand it. Like, I've seen CRUD implemented. I've got some ideas on the implementation of this, but I have not ever seen it truly implemented. So to see that would really help me solidify the understanding of it.
Gotcha. It's tricky finding sample code on this stuff that isn't like way off in the weeds. Bear in mind, I had a hard time writing this outline, and I've done this.
Yeah,
but it's like looking through the resources, you're like, holy crap, these people can complicate anything.
Yeah.
It's like the first time I actually dealt with a neural network in C#. I'd read all this research and, how they were doing this and all the math, with the big sigmas and all this crap all over the place. It's like, oh, that's all that is? Because when you actually do it, it doesn't look like this.
Yeah. That's what I'm saying. Like, I would love to see the code.
Yeah.
And I'm calling out to any of our listeners that are interested in this, please comment. If you know of like a GitHub repo or Bitbucket or anywhere with a public repo that I could just go and look, and it doesn't even have to be in a language I know. Yeah. I can learn enough of the basics of another language.
It's like learning about Lambda functions or expression trees or interface-based programming or, inversion of control type stuff. Like you sit there and you just beat your head against the wall and all of a sudden there's a moment of clarity and you're like, oh, that's not hard. Why did I have a hard time with that? And that's kind of what you're going to do if you do this.
Yeah.
Like that's just part of the
I just need a
part of the path.
Site course on it.
You're going to Mordor and getting your finger bitten off by Gollum. That's just all it is. It's no big deal. That's actually not a really encouraging thing. Another thing that is handy is that you can, if you've separated the command and the query out, it makes it a lot easier to store different projections of the data for different pages. And back to the order details thing, right? You got an order record with a whole bunch of details. When you're showing it to the client, it looks a certain way. When you're showing it to the shipping department and there's other stuff under that aggregate root, you're going to project that differently. You can store both of them, in different models with the same, with a cache key that is based on that aggregate root ID. And so when you invalidate the cache, you can hit both places without having to do any kind of weird stuff, essentially.
So the final thing we're going to talk about is kind of a big point, and it's something that goes hand in hand with CQRS, and that is event sourcing. And according to Martin Fowler on his blog, event sourcing ensures that all changes to application state are stored as a sequence of events. Not just can we query these events, we can also use the event log to reconstruct past states and as a foundation to automatically adjust the state to cope with retroactive changes. Proper CQRS implementation makes this a lot easier, which is kind of why we're talking about these two things together.
Yeah, and really, I think of CQRS as kind of the beginning phase of it, and then event sourcing is essentially going, hey, let's put this same concept in the database and actually hang on to these events permanently.
The basic idea is that as commands are processed in an event model, they're captured in event objects, which are stored alongside the current state of the domain objects for as long as the domain object exists. This is kind of analogous to the way your bank keeps track of your transactions, events, along with keeping track of your account balance, the state.
Right. And it offers the same benefits, right? Like, so let's say that you've got one of the big corrupt banks in this country that screws you over on overdraft fees, maybe because of the way that they ordered the transactions during the day. So they took all the withdrawals out first and then they put the deposits in. But if you dipped below zero, you got hit with an overdraft and then they put your deposit in. So they automatically got $30. Bank of America got busted for this, I think. Was it Bank of America? It was one of those.
They did that. I complained about them doing that back when I had an account with them. So yeah, I believe that they
got hit. If they wanted to fix that, well, what happens? Okay, well, you have all these transactions that went in a certain order, and then you have, oh, hey, they went below zero, so let's tack on an overdraft fee. Now you've got less in your account. Tomorrow you spend more money that you would have had, and you get hit with another overdraft fee. So there's a sequence of events that occurs. And so
before I learned to keep a buffer in my account, back when we were in college, this happened a lot.
I remember.
And there were times where my entire paycheck would be gone in 2 days because of that.
Shenanigans, yeah. And they did it to, that happened a lot. And they finally realized, hey, this isn't a good idea. But let's say you realize.
Trouble for it.
Yeah. Well, let's say that, okay, the government's come down on you on this thing. How do you unroll that? Because what are you going to do? Oh, I'm going to just roll back the overdraft fees. Which overdraft fees? I can't roll back all of them because some of them you legit earned.
Yeah.
So what do you have to do? You have to say, okay, what was the state before I started doing this? And I'm going to change the rule that gets applied, as events come in. In other words, to say, okay, you have to have been below this amount for a day before an overdraft or something like that.
I will say this.
Or reorder the events within a day.
No, that makes sense.
Which is probably what they did.
Yeah. I will say this. Bank of America, we did kind of trash talk them, but if you remember when I was over in Ireland the second time, I had saved up like 2 or 3 paychecks. It's like I didn't go out for
I remember
a month and a half before I went, and I'd saved up 2 or 3 paychecks, the last 2 of which bounced.
Yeah.
While I was in Ireland, because while I was over there, the company that I worked for went out of business. Like the owner, I don't know if she got arrested or what, but big things happened. They went out of business. The last 2 paychecks I had bounced, and I'm over in a foreign country on a school trip with all the money that I had saved up gone.
And that's a pretty ugly situation.
What I was getting at is, we kind of trash talked Bank of America. When I got in touch with Bank of America and explained what happened to them, they removed all of those fees.
Right. And they restored the account to the projected state that it would have been in
Yeah.
had that never happened. You can't do that without an accurate history that you can actually replay.
Mm-hmm.
This is not an audit trail.
Yeah.
Right. Because audit trails have a whole bunch of other crap in them. And, it typically tends to be, okay, what was this, what did it look like at this point? And then what did it look like at the next point? That's how audit trails tend to be. It's like a snapshot of state, at least most places I've worked. Whereas here's the sequence of events, because I don't really care what the state was then. I care what it should be. And I need to be able to roll that back and restream the events. In other words, it lets you fix programmatic errors in a lot of cases after the fact.
Which is really nice.
Yeah.
So these event objects will then show the sequence of events that cause the objects to be in the current state. It's a recognition that the events leading up to a state are also valuable, both currently and for unknown future purposes, like with what happened to me, where the company I was working for went out of business and the paychecks bounced. Because I remember you paid for my plane ticket, because when I got back, we were supposed to go to a conference and you paid for my plane ticket to get there.
Yeah, because otherwise you weren't going to be able to go after you'd already paid.
Right.
Yeah, I remember that. That was 2001. Mm-hmm. That was July.
Yeah. What's crazy is we get to the conference and my old manager calls me. Somebody had bought the business and offered me my job back. You remember that?
Yeah.
Like we had just gotten there. We're sitting down at a barbecue, and I think one of the higher up guys had said, "How are you guys doing?" And I told him I just, what all happened. And he's like, "Dude, you need a beer?" He handed me a beer and my phone rang.
Yeah. I do remember that. It's like, and there's Beej's luck kicking in again.
Yep.
At least he'll pay me back for the plane ticket. Did you?
You got the larger room in the apartment. That was the deal.
Oh, for the plane ticket.
Yeah, we paid.
Dang, I did good on that.
You did, yeah.
All right. Good. Smart on me. That was almost 17 years ago.
I know.
Like, why would I know that? If I had an event stream, I could look at it.
Speaking of events, next we're going to kind of go into some of the things that we can do with a good event sourcing implementation. First, we could completely rebuild the current state. That happened with my bank account when the paychecks bounced.
Yeah.
Bank of America was able to rebuild the current state based on, what the data they had. Since we're capturing events alongside the main domain objects, we could rebuild that state if we were to find an error in our previous implementation, or if something out of someone's control happens. This can be helpful if events arrive out of sequence.
Yeah, so if you got a distributed system, I think Evernote does this. I don't know that they do it all that well. At least when I had it, they didn't. But like you're in offline mode and you're changing stuff in a notebook. Like it keeps track of those events, like what you've changed in the diffs. Git does this too, right?
Yeah.
You could almost look at it that way. And then when you get online and you sync, it pushes those events. What happens if you touch it on another system? It's got to get those things in order. And if it's not, an actual collision, they can do that fairly seamlessly. Another thing that this can do for us is we can determine the state of an object as it existed at a particular point in time, according to the current business rules.
Yeah.
Right. Because if we change the business rules after the fact, we can, we could backdate stuff and say, hey, if you did this action before this point, you get this, and you're in this other group and something else happens. We can actually just replay those events up to a certain point and go, okay, now let's query those aggregates and look at it. That's totally a thing you can do.
We could also replay the stream of events on a particular domain model, but process them into a different structure for, say, reporting purposes.
Right. And we're, we run into this a lot at work because our database was initially built as, hey, it's a running system and, it's OLTP.
Yeah.
And then people run it for a few years and they want, hey, I want a report. I want this report. I want that report. Well, for the reports to run fast, let's put lots of indexes, and all of a sudden our writes start slowing down. So we got to take indexes out. And it's like, okay, well, what we really need to do is have a sequence of events that we can play and say, apply this event to this other thing, cram it in there. Like, you can totally do that. But if you just have the state, that's a lot harder to do.
I wish I worked with someone who understood the practical application of this so that I could see it in a complicated code base.
Yeah. Well, nobody starts with that.
No.
I mean, that's the other thing too. Like, we don't have that. We've been around for a while. and it's a big company, or well, it's we've got a huge client base, and a lot of data in the systems. But
I'm just looking at this, going, I know how this could benefit us so much.
Yeah,
but I don't know how to implement it.
And we can also reverse an event. In fact, it can be useful to allow them to reverse themselves.
Sort of like the undo or Control Z.
Right.
Which Control Z is nice. Control Y is even nicer.
Yeah.
Because sometimes you hit Control Z one too many times.
Yep. And so being able to go up, basically go up and down that stream of events and say, I want to be at this state.
And then move separately from there. I love that.
And if you're storing in a database, that's potentially possible. Now, the other thing you could do is you could have separate events. So you have, one event that does the thing and another event that reverses the thing. And this is sort of like you would do in an accounting system. Accountants don't use erasers. They make an adjusting entry instead of fixing the thing they screwed up.
Yeah.
And so you may want to have that.
Well, that's like my bank does a thing where they charge you a monthly maintenance fee unless you have a direct deposit, and then they charge you the monthly maintenance fee and then immediately give it back to you.
Yeah.
So finally, we're going to talk about how this works in practice. And Will got a lot of this stuff from a GitHub wiki on event sourcing basics. And we'll have that link in the show notes. Events are stored in their own objects alongside the domain object.
But yeah, this is a critical point, and I know we've hit this before, but it has to be stored. You have to have it when you need it.
Yeah. A lot of times a read model of the domain at its present state will be stored and updated as each event occurs.
Right. Like if you want to query state, you just about have to have that.
Yeah.
Right. Because otherwise, like how are you going to actually query something when it's an event stream? Well, when this thing runs to its end, it's going to have these values. That means that the query processor is going to have to run all those as it's going through, and it can't index.
Right.
So you're going to have the current state stored somewhere. This was a big thing. I had a hard time understanding the value of it because I was like, well, how do you query this? And they're like, no, you don't query this. You don't. You make a read model and you query that.
Yeah.
But you write to this. Like I had a very hard time when I was messing with this stuff, understanding that it's like, look, it writes it in, but it also updates the read model. So it's two copies of the same thing. One of them is the state, the other's the event that caused the state.
Okay. I'm starting to get like a picture of the practicality in my mind.
Yeah.
For this.
And it took me forever to pick up on that. And then one day I was like, oh, that's what they mean.
No.
Which is why everybody was acting like I was an idiot when I was asking this question, because it's kind of a stupid question until you understand the thought process that's going in here.
Well, when that goes back to what I was talking about on our live feed about thinking like a programmer or thinking like a developer, it until you are there, it doesn't make sense. And then once you're there, not understanding it doesn't make sense.
Right.
So it's kind of a Boolean, really.
Yeah.
It's an on off. Once it's on, you get it, but you don't understand what it's like to not get it.
Well, and that's a big thing with human nature too. Like look at just to give an example, look at the reaction to the flat earthers. Right? Like, I mean, I get that they're wrong. Okay.
No.
But look at the emotional reaction.
I saw this thing on Facebook where the Flat Earth organization had posted, "We have members all around the globe."
Nice. Yeah.
So if an event was made an error, an adjusting event is sent in to reverse the change. As we've mentioned before, this is sort of like adjusting entries in accounting. And, as we're talking about the practicality, we've kind of peppered it throughout the episode, but we're getting to the specifics right now. In complex systems with an object relational mapper, or ORM, you may be tempted to lazy load. In an event sourcing scenario, you can just load all of the events from one table, no joins, for a particular aggregate root, then replay them on the item in memory. And this can reduce the need for joins on the database server. Occasionally, this is handy.
Yeah, well, I'll give you an example. Let's say that you have Amazon's order tracking system. Again, order and order details.
Mm-hmm.
You might have 100 million orders, right? So you go out and you say, okay, I've got to get this one order, but but I've got to get all the detail lines for it. And there may be 15 detail lines, but you think about how many records are in that order details data store. And then I got to go over and jump over and get the shipping information. And shipping information, I'm tying off to the user record, and then they have an address attached to that. And, and I got to figure out which address and go get it. And then I've got to get the shipping rates at that point in time. So I got to do another join. So there's like 10 joins for this data. When what I really want is I want to say, okay, here's the order ID. Give me all the stuff that built that up because all the pieces are there. And then I create a new one and mutate it real quick in memory. So I just say, give me a chunk all in one shot. So it's a real simple query and you don't have joins, because the big problem with that is you do big joins like that. A lot of times you end up locking a lot of data that other processes are trying to get into, and they have to wait on you.
Oh, that makes sense.
And vice versa. So if you just go, hey, I'm getting out of one table, just give me the thing.
Synchronization requires getting all the events for an aggregate route since the last one you got, and then replaying them. It's a lot easier than a database synchronization. Also, it doesn't require both sides to represent the object the same way.
Right. So, for instance, let's say that you have a document database and you're reading out of that for the front end of your website. Like you got a super popular, let's say you got a super popular development podcast, and each podcast page has a document for the data that's on that page. Well, when you're building the back end system, you've got all this other stuff that's changing all the time. And then when you publish it, puts it over here. Well, if you have an event stream type setup, you can just say, hey, I'm at this version. Are there any new versions? And if so, give them to me.
Okay.
And then you play it against that document database that's not the same structure as the entity relational structure you have on the back end. So you can write that out as JSON and it's fast cached.
Okay. So I've seen this sort of a little bit. I can see where we were going that direction, but it didn't quite make it all the way to there, because our view models can be a little bit different than our data models. Sometimes I do that because, there are things that's just easier for the front end to pass in as an object, but it's just one of them that's ever going to go in. It's like an object of two fields that it's easier for them on the front end to send it in that way, but storing it on the database, there's no point in creating a separate table. Like that's just...
Yeah, you just apply it to that other structure.
Right. Now that I get, that makes a lot of sense.
And the nice thing is too, if you're doing this in a relational, you got a relational database and you start out and you're going, okay, I'm going to do event sourcing. When you do finally add that document database, it's not as painful to move it over. If there will be a lot of events for a particular aggregate, you can also do something about that. So you're not having to pull all the events from the beginning of time. In this case, you would actually set up a rolling snapshot. So you'd have a projection of that event. In other words, your aggregate route stored as a read model at a particular point in time with the version information. And what you can do from there is you can take that version information off of this aggregate and go, give me everything since then that has changed, and then you replay it on the object. This is kind of something you're not going to do a lot until you get a much bigger system, but it's nice to have that option because you may not necessarily want to apply all the events, right as they occur directly to the read model. In other words, like let's say you're calculating, bank balance. You don't update the bank balance until a nightly batch job, because this is the way it used to work. A long time ago. That's why people did stuff like kiting checks and all that. Is your bank balance was calculated at night, by a batch process, and transactions came in during the day. So you could think of that nightly process as a snapshot of the data sitting there.
Note that this is a process model, not a reporting model. If you need things projected for reports, you can process events and store the results in an appropriate way somewhere else.
Right. And that somewhere else, by the way, doesn't necessarily have to be directly connected to your database server. It can be in a different database server. So you can have an app sitting between that pulls from one to the other, and you don't have the replication problems between the two. I'll also tell you that this does a decent job of reducing the impedance mismatch between your code and the database, at least for the purposes of OLTP, right? Because you just want to get the transaction in and then deal with other stuff later. You can do that. Because if you think about it, most of the time when you're taking an action, you don't actually need immediate write of the whole thing and the state, completely caught up. For instance, you do a credit card transaction at the gas station your bank balance is not going to reflect that if you're looking at it on the phone 10 seconds later.
Usually not, no.
Right.
Sometimes it does.
Yeah, it's weird how it happens, but it doesn't have to. The bank gets under load. That doesn't mean the credit card machine goes down.
Right.
That's the idea.
Mm-hmm. Yeah, it's funny. It's gotten a lot faster because I can remember when we were in college, you could buy something.
Yeah, and then walk down the street to the bank and make a deposit.
Yeah.
Yeah, because we did that a couple times. Because it was like liquor store bank.
Yeah,
right there.
That's very true.
Because we go on our long walk.
Yeah,
and do that. We would pick up our booze
and then go to the bank and cash our paychecks,
and then walk back to the apartment. It was like clockwork.
You guys, command query responsibility segregation and event sourcing are both advanced development concepts. Like a lot of advanced concepts, these can be difficult to get your head around the purpose of them. However, once you understand what they're trying to do, it gets a lot easier to understand what is going on. The hardest part is when you don't have the practical to see for yourself. You can understand the concept, but not know the implementation. Once you have seen the implementation, it then becomes easier to understand the concept. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I want to touch on an interpersonal thing that kind of came up while we were discussing this, and that is there's people that have certain pieces of information and certain understandings of the world. If you notice, they get really, really frustrated when other people don't have that same understanding, and you'll see this in a corporate environment a lot. I've worked with engineers, for instance, like electrical engineer types, for instance. They have a coworker who did marketing and doesn't understand how a circuit is put together. And so they make this, they're like, well, why doesn't this work, in this way? And it's like, that's not how that happens. And you'll see the engineering types get really frustrated. You'll see the marketing types get frustrated at developers the same way because we don't understand what it is to build a brand, how to structure things. Most of we as a community are not real good at that. So you'll see people get angry, and they're getting angry not because somebody doesn't understand something, but because they cannot understand why they don't understand. It's a meta anger. And so be aware of when you're doing this as a developer. Like sit there and think, okay, I'm getting angry at this person for not understanding something. What fundamental piece of data do they not have that's making them not understand it? Rather than defaulting to thinking that they're just being dumb or they're just causing a problem. I just want to throw this out there because I've seen this a lot in my career, and it is literally never helpful. But if you do sit there and try to figure out what that piece of data is, then you can build bridges between departments, and you can be really critical to an organization. Just want to throw that out there. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Look for us each week on Facebook Live before we record each episode. Thanks for listening. See you next time.